In this lesson, we are going to look at standard deviation. We're going to be able to determine the standard deviation for sets of data and use it to solve problems and make decisions. The coach of a varsity girls basketball team keeps statistics on all the players. Near the end of one game, the score is tied and the best starting guard has fouled out. The coach needs to make a substitution. The coach examines the field goal stats for two guards on the bench in the last 10 games. So we've got Morgan and Paige, and we've got their field goal percentage in their last 10 basketball games. How could the coach use the data to determine which player should be substituted into the game? So think about what the coach might be looking at with this data. One of the things that people often go to is the mean of the data. So let's first of all find the mean for each of these players. So for Morgan, it's a matter of adding up all of her values, and then there are 10 to divide it by. So we'll start by adding up. And we get 358, divide by 10, and her average is 35.8, and that's percent. So now we look at Paige. And we add up Paige's values. And we get 339. When we divide that out, we get 33.9%. So now what we do is we can make a decision. So the coach might feel that since Morgan's average is higher than Paige's average, he's going to choose Morgan. So at this point, we have investigated several concepts from data analysis, such as mean, median, and mode. But there are many, many more that we can use. Deviation is the difference between a data value and the mean for the same set of data. So if you've got Paige's 10 percentages from the last 10 games, and you found her average, you could then actually find the deviation, which would be the difference between each game's percentage and the mean for all of her games. Standard deviation. This symbol here is used to represent standard deviation. This is a measure of dispersion or scatter of data values in relation to the mean. A low standard deviation indicates that most data values are close to the mean, and a high standard deviation indicates that most data values are scattered farther from the mean. And there's the formula that we use for standard deviation. So this symbol represents standard deviation. This symbol here is called sigma notation, and it represents finding the sum. The mean is represented by x with a line over top of it. N refers to your number of data pieces or data values that you have. So if we think of the basketball one, that would be 10 games. So there's 10 pieces of data. And that's how we would find our formula. So what we're going to do is we're going to complete the following table. What we need to refresh our memories on was the mean for Morgan was 35.8. The mean for Paige was 33.9, because we are going to need that. So the first thing we are going to do is we are going to find the deviation. So the x value, which happens to be 34 in the first one, subtract the mean. So in each case here, we are going to subtract the mean all the way down for each of these pieces of values. So what we have done here is we've found the difference between the data value and the mean for each of those pieces of data. Now what we want to do is we want to square those deviations. We don't want to worry about whether the deviation was above the mean or below the mean. We simply want to find the square of these deviations. So what we're going to do now is we're going to go through and we're going to square each of these values all the way down her list. So now that we've found the square of each of these deviations, we want to determine the mean of this column. So we're going to add up each of those values, and there are 10 of them, so we are going to end up dividing by 10. And we get 81.36 is her mean. So this is the first step in finding standard deviation. First of all, you find the average or the mean of the original data values. Then you find their deviation, you square their deviation, and find their mean. Now from here, to find the standard deviation, we square root this mean. So we square root 81.36. And the square root of that is 9.02, approximately. So now we have the standard deviation for Morgan's field goal at 9.02. Well, what does that mean? Well, let's first of all have a look at what Paige's is. So we're going to repeat this process. But in Paige's case, her mean was 33.9. So we're going to subtract 33.9 from each of these data values. So that's the first thing we are going to do. So once we've found the deviation, now we want to square each of these values. So we're going to take the deviation and we are going to square each of them. And once we've squared each of the deviations, now we are going to find the mean. So we are going to add all of them up and divide by 10. And we get 0.69 is our mean. To find the standard deviation, we find the square root of this value. It's approximately equal to 0.8. So now you can look at this and you can determine better information. If you're looking at it here, although Morgan's mean of her field goal percentage was higher than Paige's, when we look at their standard deviation, Paige actually has a better result. Paige is very close to her mean every time. And if you look at her data, she ranged from 33 to 35. So her percentage is very consistent. Where if you look at Morgan's, although she averaged higher, her standard deviation is quite high at 9.02. It means that her values are very scattered. Either she's really good, she's up at 44%, 43%, 41%, or she's really low, 19%, 21%, etc. So you have to, looking at it here, then you might be able to ask yourself some deeper questions. Do you want the most consistent person, or do you want the person that may do it at a higher percentage? But then they could also really end up at a lower percentage. So some things to think about. What standard deviation does is it tells you how the data varies about the mean. So a lower standard deviation means more consistent around the mean. A higher standard deviation means there's more variation off of the mean. So here we have a machine packaging candy in 90-gram packages. It's thought to be faulty. A sample of 10 packages is randomly selected, and the actual masses in grams are the following. In order that the machine works properly, the standard deviation must be less than 1.3 grams. So is the machine faulty? So we have to find the standard deviation. So step one to finding standard deviation is, first of all, find the mean of your data. So we have to count. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 10 pieces of information. So we are going to add up those 10 pieces of information. And then we are going to divide by 10. So what we're saying is that the average of the packages that were pulled is 90 grams. So now what we need to do, in order to find standard deviation, the next thing we need to do is find the deviation. So our packages are, it's easiest to set this up in a chart form. So we have all of our data listed here, and we're going to subtract the mean off of each. So we're going to, when we subtract 90 from each of these, we are going to end up with -4, 1, -1, -2, 2, 0, 3, 0, 0, 1. So then the third thing we want to do is square the deviation. So we want to take each of these values and we want to square them. So we're going to end up with 16, 1, 1, 4, 4, 0, 9, 0, 0, 1. Fourth thing we do is find mean of the squares. So we're going to add up this column here and then divide by 10. So we have 36 and divide by 10. We have 3.6. And then the last step is to square root the mean. So we're going to take 3.6 and we are going to square root it. And we get 1.897, so approximately 1.9. Now what the question asked us was, the standard deviation had to be less than 1.3 grams. So we have 1.9 grams, so is the machine faulty? The answer would be yes. The machine is faulty. Because our standard deviation was more than 1.3. So when data is concentrated close to the mean, the standard deviation is low. When data is spread far from the mean, the standard deviation is high. As a result, standard deviation is a useful statistic to compare the dispersion of two or more sets of data. Standard deviation is often used as a measure of consistency. So we're looking for a consistent product. When data is closely clustered around the mean, the process that was used to generate the data can be interpreted as being more consistent than a process that generated data scattered far from the mean. So a lower standard deviation implies a more consistent action. Remember your steps to finding standard deviation. First thing you do, find the mean of your data. Second thing, find the deviation. Third thing, square your deviation. Fourth, find the mean of your squared deviation. And the fifth thing is then square root this new mean, and you will have your standard deviation.